Hey, what's going on? Adam the Tutor here, coming at you with another Laplace Transform problem. This time we're doing hyperbolic sine, and basically it's exactly the same. It's really the exact same problem. Just there's it's the exact same problem as the hyperbolic cosine. Just instead of a plus sign right here, there's a minus sign right here, right? And let me erase that dot there. But, so basically that's really the only difference. So without further ado, let's jump into this one. So we have the Laplace transform of hyperbolic sine is equal to the integral from 0 to infinity of 1/2 e to the a minus s times t minus e to the minus a plus s times t. So you can already see the resemblance here between this problem and the last one. So here we're going to have a 1/2. We're going to have an a minus s e to the a minus s times t. And then we're going to have a plus here, e to the a plus s, and of course there's our minus right there, t. And then here we're going to have our a plus s, right? And we already took care of our minus sign that comes down when we integrate this, right? Because this minus became this plus, right? So, and of course, we have our boundaries from t is equal to 0 to t diverges off to infinity. And as with the hyperbolic cosine case, we're going to have that s is greater than a, right? So, basically, now, it's really the same story. We evaluate this in the limit that t approaches infinity. It's 0, so we get minus 1/2 at t is equal to 0. Both of these exponentials become 1, and we're going to have a situation where we basically just have to do a little algebra. So, and it's the same common denominator as in the last video, right? If you square this out, we get a squared minus SA plus SA, and then we're going to have minus S squared, right? And we can bring down the negative in the denominator, and we can cancel out the S's, and we'll have 2A. So basically what that's going to result in is we're going to have A over S squared minus A squared, right? So all we did was combine this denominator with this denominator, got it to be equal to this guy, and then we canceled off our s's, and we found that the numerator is 2a, which cancels out with this 1/2, right? So we just get a, and then we brought the minus sign directly into here, which flipped this, right? So now we have our final answer, that the Laplace transform hyperbolic sine of at is equal to a sine squared minus a squared. And again, I mentioned this in the hyperbolic cosine, the hyperbolic cosine video, that transform was very similar to cosine of at just with a plus sign. And it's the same story for hyperbolic sine, right? If this was a plus, then, this h wouldn't be here. This would just be, regular sine at. But with that being said, that's going to do it for this video. And if you have any questions, comments, or maybe you'd like to see me do another Laplace transform problem, or, you got your own suggestion, feel free to drop it in the comment section below, and I will do my best to address it. And as always, thanks for watching, and I will see you in the next video.